Hello, everyone. My name is Kelly Sims with Blastwave. Welcome to our three-part webinar series on Zero Trust Network Access and Compliance. For today's topic, Simplifying Zero Trust Network Access and Accelerating Zero Trust Compliance, we will explore the Zero Trust concepts of never trust, always verify, and always assume breach. We will break down the principal tenets and approaches of Zero Trust architecture while identifying the challenges of the requirements of ZTNA and provide a detailed description of different ZTA deployment models, including software-defined perimeter approach, which will be the headliner for our second webinar in the series, where we'll take a closer look at SDP, which we think is the best model in implementing Zero Trust. And in the third and final installment of the series, we'll provide a technical overview of Blastwave's Blast Shield ZTNA solution. Now I'd like to hand the floor over to Tom Sego and Kayal Kaindet. Hello, gentlemen. Let's get into Zero Trust.
Thank you, Kelly. Great job there. Love the topic today and excited to have Tom on with us today. And why don't we dive right into it, Tom?
Yeah, sounds good, Kale. I'm really excited too. This is such an important topic that a lot of people are struggling with, and I really like the opportunity to share our view on Zero Trust and how people can help get that journey towards a kind of brighter future, a more secure future. So I'm excited about this.
That's right. I think Zero Trust is one of those terms that has been around for a little while and people are talking about more and more, but both the vendors that are talking about it, as well as the people responsible for actually implementing it, don't necessarily understand all of the pieces around where it came from, what it really means, and what you need to comply with. And today I'm hoping we can shed some light on that.
Yeah, definitely. And I think this slide that you have up there kind of shows an encapsulation of the big problem and why Zero Trust is so important. If you look at the spending in cybersecurity today, it's growing at double digits, but yet ransomware is growing at almost triple digits. In fact, it's almost up 5 to 6 times in the last 2 years due to the pandemic, more sophisticated credential harvesting and other things. And it's also, I think, interesting to note that the rate of ransomware increase almost correlates directly with the increase of cyber insurance premiums. So this is not just affecting people's reputation and leakage of data, but it's also affecting their insurance costs or their ability to even get insurance.
We think a lot in terms of breach and vulnerabilities and impact, loss of compromise of data that's supposed to be held private, but insurance and cyber insurance is really rising in importance. Tom, can you talk a little bit more specifically, maybe even specific examples of how enterprises are having to deal with cyber insurance challenges?
Yeah, definitely. I mean, if you think about, I'm going to give you an example. There is a hospital that in hospitals typically need to have high amounts of coverage because of HIPAA requirements, HIPAA fines, and the insurance can sometimes pay for those fines and address those shortcomings. There was a hospital that was receiving 10 million in coverage and last year. And then when they went to apply to renew their insurance policy, their coverage dropped from 10 million down to 6 million, and their insurance premiums simultaneously increased 360%.
It's crazy.
And it's crazy, but this is excruciating pain for a lot of customers. Furthermore, there have been many people who used to have cyber policies that are not able to get them anymore because the insurance companies used to make a ton of money on cyber insurance 4 or 5 years ago.
That's right.
But today they're underwater and they're scrambling to try to figure out how to come up with a profitable business model for cyber insurance.
Right. I mean, they were essentially underwriting anything to get the numbers. The actuaries wanted the numbers, tell me exactly when are things going to break down? How much am I going to be liable for? And that happened. And now they're underwater, or not underwater, but the dynamics and the economics are changing.
Yeah.
And I think fundamentally that has to do with the changing landscape and also just the fact that we're still using an architecture for security that's 30 plus years old.
Yeah.
So,
And this chart really kind of shows the big three horsemen, as I call them. Credential theft is by far the leading way that hackers get into a network, do the reconnaissance, and then further figure out where their targets are to establish backdoor command and control to breach their data. Credentials are by far the biggest issue. And so if we can come up with solutions that can, for example, have phishing resistant MFA, that's a huge step in the right direction. I think another area that's also, I think, well understood is that bugs are oftentimes converted into vulnerabilities that can be exploited. And there's obviously the MITRE.org has all the CVEs listed there, and you can go there and look at it yourself. And then the toughest thing is zero-day viruses, because those are attacked before they've been published anywhere by definition. But then there's also this third area, which is really hard to get your head around, which is around human error. And frankly, the 10% may be understating this, because this was just related to configuration errors. But humans make kind of either trying to work around controls or just trying to figure out how to implement something. Oftentimes there's holes that they inadvertently create that hackers can then exploit.
yeah, exactly. We talk about this notion of security by design, but oftentimes once humans get involved, it's almost like vulnerability by design, because they take the system that's been built, but to make it more convenient, maybe easier to manage and access remotely if you need to change something late at night, they design the system so it's easier for multiple people to be able to log into the same machine. So I call that vulnerability by design.
Yeah, and it oftentimes happens where someone needs something urgently. They need access to something that's down. It's affecting one of their customers, and so they just create a workaround, or they bypass a control, or they turn it off.
Exactly right. And this credential theft, this is part of what has really driven the need for zero trust, which is you have to assume today that you have stolen credentials within your network. These aren't just people outside of your network trying to get in, but the reality is someone is in your network, likely right now, that has compromised your security in some way. It doesn't matter whether they're outside of your enterprise set of firewalls or inside. And
exactly.
I think there are a lot of really important trends that we're dealing with today that are making this problem even more challenging, right? So there's the cloud. The organizations are still migrating applications to the cloud out of their own data centers. The pandemic brought a brand new appreciation for what it really means to have a remote workforce. And this notion of IoT is just moving devices outside the perimeter, and that in itself is disappearing.
Yeah, and the cloud comprises so many different components too. You've now got infrastructure as a service, platform as a service. You've got software as a service, and then you also have microservices that are being delivered via containers and Kubernetes clusters. So it's a very nuanced, complex environment that people are struggling with today, and it's fairly new.
That's right. And bolted on top of that, which I think many people don't really appreciate, is that these enterprise companies that have traditionally purchased software from third-party vendors from ISVs for decades are now building their own applications and building more and more of their own teams in-house to handle things like all of the DevOps functions.
Yep.
So they're becoming software development companies themselves. And certainly they've done it before, but not at this scale.
Yep.
And they don't have a lot of the security controls in place for their dev environment, right? It's sort of a set of engineers that are developing things, and they don't necessarily have the watchful eye of IT managing their GitHub repository or their servers, right? Which are on their computers. They have developers all around the world. Getting your arms around that security is very complicated.
And the developers are probably the highest qualified group of folks to find a workaround.
Yes. Yes, they are also, in my experience, the main group that would prefer to not to have as little security as possible, to make it easy for them to develop and test rapidly, right?
Yeah. Yeah.
And it's through no fault of their own, because many of them are not security professionals, and they don't have that depth of security on their team oftentimes. So they're just building things to make them work, and then thinking about security for their environment or their products later, oftentimes.
Yeah, which is the whole shift
challenging.
left kind of concept that's
Exactly.
taking over DevOps. Yeah.
Exactly. So zero trust. We're talking about it. We'll go into more details. I think that it's that the timeline is very interesting. You know, we're talking about the term being coined only in 2018 by John Kendervag at Forrester, and he came up with this notion. I think there were many other discussions around that time, but he came up with the term zero trust. In August 2020, the US NIST published a great document called Zero Trust Architecture, NIST 800-207. And that is something that we're going to dive into the details today, but it really defined for the first time what a zero trust implementation should look like. CISA came up with a zero trust security model shortly after that. And then it really accelerated with the White House issuing the Executive Order 14028, which basically began to lay out the requirements for organizations, especially federal government organizations and agencies, to begin to comply with this notion of zero trust. They provided the responsibility to the Office of Management and Budget to define that further. And they did that in January of 2022 in a long memorandum called M2209. And all of these documents are available. We have links to them in a white paper that we'll provide to you later. But the OMB was significant because it actually turned it from a discussion about frameworks and best practices and architecture to mandates.
Yep.
Two of those things. Why don't you go into two of those mandates, Tom?
Well, I think, you know, as we said on that other pie chart, credential theft was the #1 issue. And so not surprisingly, in this OMB 2209 memorandum, phishing resistant MFA is at the top of the list. And that has to be one of the options that is implemented by January of 2023, which is not far away, like a month. And then the other thing that was important is, you know, they try to kind of do the 80-20 rule and distill down what are what's the low-hanging fruit to try to implement a zero trust architecture. And so then they've said that requirement needs to be done by 2024. I'd love to see in the comments below, you know, who has actually read NIST 800-207 or read the OMB 2209. I mean, for a security person, it's very exciting to read these things.
Right. I think the challenge also, or always with these documents, is they provide the guidance, but they don't provide the real, or they provide the direction, maybe some frameworks, some general requirements, but they don't provide you the how-to, right?
Yeah, and it's super difficult because every environment's different. Every entity, every organization has their own baggage. They have they're on a path on this zero trust journey, and they're at different stages and they have different requirements. And so it's quite a process, much like when people would implement ERP solutions in the past. They had to go through a re-engineering of business processes. And I feel like zero trust mirrors that in a lesser way, but equally as important.
Right. Yep. So what is zero trust? When you look at the fundamental aspect of zero trust, there are two concepts that are important. That one is you never want to, is you don't trust, there's no implied trust. whether the person or the resource that you're trying to access is within your network or outside of your network. The first step is you don't trust anyone, and you always have to verify first, authenticate first before providing access. The notion of network-centric security has been with us for a long time. So think of way back in the 1990s as the internet was emerging, and we were beginning to move from private networks on proprietary protocols to a TCP/IP based model. We began to develop many layers of network security, right? Layered network security. And that's what we have today, but it's all focused around the network, and it assumes that you control things in a certain way through managing your subnets, by providing, by managing things through VLANs.
Talk about human error. Talk
Right.
about human error. Holy cow.
Right,
Managing
exactly.
I take my hat off to the network engineering teams that are trying to manage this stuff.
Right. The challenge is that now that the users have left the castle, right? The whole castle and moat idea is not really relevant anymore. All the users are outside of the moat, right? And now so are the assets, IoT assets. And now all of the data center, all the data and applications are moving outside of the perimeter as well. So what's left? Well, nothing really. The perimeter, the network perimeter has all but disappeared, which is why I think zero trust is such an important concept and approach for today to migrate away from the model that we have today, where we're seeing all of these theft of credentials and compromise.
Yep.
Let's see. So, NIST 800-207, the ZTA, the zero trust architecture. Do you want to talk a little bit about, how organizations might be thinking about and zero trust and your some of your impressions of the ZTA document?
Yeah, I think the ZTA document was the first of its kind to, I think, establish some pillars, 7 of which that kind of structured how to think about a zero trust architecture. What is it? Because one of the problems was, once the government said this is important, and once security professionals realized how critical this is, we started seeing zero trust branded on everything, right? I mean, I went at the RSA conference last, was it May? No, June. The RSA conference in June. I swear, half of the companies there had zero trust on their banners. And so there's this confusion between branding something as zero trust and making these claims versus this 800-207 document, which lays out these 7 pillars. But I think fundamentally, Cal, you kind of captured the essence of it best when you say you have to establish, you have a control plane and a data plane, and you have to manage access between all entities and the resources that they're trying to connect to and operate within. And so you don't even think about perimeter. It's about, I need to connect this entity to this resource for this session. And another concept that's very important is everything is session-based, which greatly minimizes risk. This does not cure cancer. This doesn't eliminate security as an issue, but it greatly reduces risk. And the whole security industry is really more about risk management than it is about risk elimination. I think zero trust architecture is probably the best distilled mechanism to make that happen.
Right. I think what I also liked about it was when you talk about zero trust, sometimes people just think of, oh, I think I might already be doing zero trust. I use authentication. I have implemented least privilege access and authorization in my Active Directory, and I've implemented SSO. I think I'm doing all of this already, right? And what the NIST 800-207 really pointed out was, well, yes, here's what you should do. Here's some tenets, and also here's some ways of approaching it. And we have some very strong opinions about how companies can best approach it, or where they should get to, and what some of the pros and cons are about some of the implementation approaches. And we're going to go through those.
Great.
Okay. The 7 tenets. Why don't you go through the first half of these, and then I'll go through the others.
Okay. So all data sources and computer services are considered resources. You've got to get the topology right and define the terms correctly, so you can then apply a framework, a security framework on top of that. And so that's just basic. The second thing is to make sure that you have encrypted communications between all the entities on the network, every single node on that network, regardless of things like location, regardless of who it is. So everything has to be encrypted. You have to have encrypted transport between all those things. The third thing is, as I mentioned earlier, everything is based on a per session basis. And there's even this concept called perfect forward secrecy, which helps manage keys, symmetric encryption keys, in a way that makes it so it's very difficult to intercept things that could be a way to get a toehold in an environment. So those 3 things, I think, are maybe well understood by the vast majority of folks. Now, when you move into things like accessing resources with a dynamic policy, this gets to be pretty challenging, because now we're talking at the feature level. It's not the principal level anymore. And you can take this even further. But, there's some examples about how you look at, is someone requesting an asset in New York, and yet 5 minutes later, their location is in, Hamburg, right? Mm-hmm. And so that's an example of a data element that needs to be incorporated in the policy enforcement mechanism.
Right.
And so those are 4.
If I can just jump in there, this is one of the things where actually I would point out one of the challenges of the ZTA model, which is number 4 and number 2 can often conflict. For example, you need to be putting in place mechanisms that allow you to authenticate each device on the network, users and devices they're trying to access. And they need to be secured, locked down, trusted, regardless of whether they're inside or outside of your firewall, your perimeter, right? Yeah. At the same time, number 4 says, well, you should be making decisions based on a dynamic policy, including information about the client. Well, you can do that, but the point is, you can't make that decision based on whether they're coming in over or they're inside your network perimeter, or they're coming in from a certain trusted IP address from a service provider, or coming in from a certain country. Those types of policies aren't trustworthy because they can be spoofed, right? We can see that all of the time. And that is the point of this. You should make decisions on the client identity. I think that's the most important one. Yep. And anything beyond that, you have to be very careful about creating a dynamic policy for.
And there is a lot of innovation that's happening in the behavioral attribute layer of this, where, for example, there may be some zero trust access tools that can determine if someone is trying to get a network connection where they're not supposed to, or they may be doing other things. And some people are even trying to apply AI to this, although I think AI is it's a great thing for us to be pursuing. I think in the practical implementation of it, it's not delivering the promise that a lot of people have hoped for yet. So
yeah, that's right. All right, let me take the rest of these. So the other have to do with, you need to monitor and measure the integrity of the security posture. So you need to have in place the systems and mechanisms to constantly monitor not only the endpoints, but also your system itself, and ensure that you can report on the security posture of all of your assets. The sixth tenet is all resource authentication and authorization are dynamic and strictly enforced. And this is the most important part, before access is allowed.
Before access is allowed, and hopefully you restrict visibility before that authentication occurs. That's the gold standard.
That's right. And think of how many times this doesn't happen today.
Yeah.
You walk into a hotel, into a into a hospital, and you can connect onto their Wi-Fi. You may even go to your customer's office and you can connect to their Wi-Fi network, and then you log into a little portal that says type in your one-time username and password, and then that gets you into the network, right? Those types of approaches aren't trustworthy, because once an attacker is on the network, they can begin to use tools that scan the network.
Like Nmap.
Like Nmap, and begin to look at things and look at vulnerabilities. So you have to handle authentication first.
Yep.
And then the last one is, just gather a ton of information. So you want to be gathering as much information as possible, sending it into a data lake, a SIM, so that your SOC can evaluate it, monitor it, raise it to an incident response team that can deal with it and take the appropriate measures, right? And constantly using it to improve your security posture. So those are the main pieces. And what I want to emphasize here is, if you've been thinking about zero trust very generally and thinking about, hey, I've implemented MFA, I've implemented some set of privileged access and controls, and I'm doing some monitoring, it may not, you're probably not meeting all of the tenets of zero trust, because you might have areas where you're allowing people to connect first without authenticating, or the authentication isn't very trustworthy, or the policies you have aren't really truly treating every single resource and endpoint like a system that needs to be protected. Okay, these next set of slides are going to get a little more technical, not too much, but it's important to understand the core components of ZTA. There are several of them. There's the policy engine, the policy administrator, and the policy enforcement point. So the way it works is this, and the NIST 800-207 defines these core components. The policy engine is a platform that's really determining who can connect to what and what can connect to what, right? It's the engine that has all of the policies. The policy administrator is actually enforcing that policy, and the policy enforcement point is something that can sit on the endpoint or the system, like a user system, or on a enterprise resource like a server or a VM, an EC2 instance in AWS. But it's a piece of it could be a piece of software that is protecting that element, and the policy administrator is handling that. That sits within the context of your overall security, right? Handling all of the identity management, the SIM, the data access policies. But this is the zero trust is a concept that uses a set of components to help you enforce not trusting and authenticating before connection, and implementing a model where you don't have any implied trust. So let's go into each one a bit more. So the policy engine is typically some set of is software. It could be a third-party software or provider. It could be something that you develop yourself. but basically it is responsible for the decision of granting access to a resource. A resource, again, is a server, a VM, etc. It's going to use policies, going to have to make decisions using a trust algorithm of some sort, and it's going to make the decision on whether to grant, deny, or revoke access to a resource. It's also going to log every decision and that's been approved or denied, and the policy administrator is going to execute that decision. The PA is responsible for shutting down or enabling the communication path. So this is that notion of, okay, I'm a system here, I'm an end user. I come into, before I get connected to any part of really the network, the policy engine is going to check my identity, verify it, confirm what I can connect to, and then on a one-by-one session basis, that will provide me access to the end resource I'm trying to connect to, whether I'm inside the network or outside. Going to do it on a session-by-session basis, and the PA is really the enforcer here. And then finally, the PEP, the policy enforcement point. So what is this thing? So it can be you can think of it as it could be a gateway that is in front of a number of resources. It can be a piece of software, a software agent that is on a host, protecting every host. It can be a software client on an iPhone or an Android phone or your smart device, laptop or desktop. But it is the oftentimes the piece of software that is taking things into account, like what's the identity, or it's managing the identity and the private and public key pairs on the devices themselves. It's communicating with an administrator. The public key of that system is probably registered with the policy engine, so the policy engine can make sure that it can confirm its identity. And that piece of software is also leveraging private keys within a secure enclave, or like a TPM within a device, to make sure that that device is trusted. And ideally, it is the device itself is the only thing that can attest to its own identity. So the policy enforcement point, or PEP, is super important, and it's either going to be in the form of a gateway fronting a device, or it's going to be software on a device itself. Okay, so how does this fit within the approaches today? Tom, you want to talk about some of these different approaches and some of the pros and cons?
Yeah, sure. So since thank you for that. By the way, I could never have done as good a description as you just did. So thank you for that. So if you think about 3 generations of secure remote access, the one that we're all familiar with was the original VPN model. And that was back when the castle was inside the moat. And so you would have users who would be in an airport or at home, who were trying to connect to their corporate resources, which were in their data center, on-prem data center. And so the way that happened is you'd connect through a VPN concentrator, and then that would constrict all the traffic through that one server. And then you'd get access to the entire local area network as if you were in the office. And that was a great way to at least enable you to get access to your corporate resources. But there were also some problems, the biggest of which were dropped connections, slow performance. You also had a bunch of issues related to authentication and visibility of public IPs that have led to VPNs being one of the leading ways that attackers gain access to critical resources. So that was the old model with the castle moat. And then in about 2010 or so, you had more and more applications going from on-prem to the cloud. And in that case, you had companies like Zscaler that would just take that VPN concentrator and wait for it. They would just move it to the cloud, and they would host all of those connections, broker those connections through that cloud-hosted proxy server. So what happened? All the users would hairpin their traffic through that single server. You would get access to cloud applications, which was great. So it solved that problem, but you still had a bunch of issues related to performance. You still didn't address the original sin of security, which is around credentials and the ability to phish those credentials. You would have the performance bottlenecks. You would also have visible public IPs that people could scan and then do all kinds of mischief once they were able to get access and visibility to that. So now enter the third arena, which is moving from this model where everything goes through a single server to a peer-to-peer architecture. And this peer-to-peer architecture is called a software-defined perimeter, which you put little pieces of lightweight software on all the different components. You have a centralized orchestrator that brokers the policies so resources can connect directly to users and people needing access to those resources. So as a result of that full mesh capability, you get blazing performance. You also don't have any public facing ports. So it's very secure and it's invisible. This also includes phishing resistant MFA, which addresses the credential issue. You don't have to deal with VLANs, access control list. You don't have to deal with certificates and public key cryptography challenges. And it's also very simple to set up. It scales, I don't want to say infinitely, but it scales much better because it's all peer-to-peer. So it's a really exciting model. And I think the software-defined perimeter model is one that we're going to be seeing more of in the future, Kale.
Yeah, oh, absolutely. And I think it also mirrors the way the workplace has evolved, right?
Yep.
Back when VPNs started coming out, frankly, in and around the early 90s, early to mid 90s, people were working in offices, right? They needed a way to communicate between offices, and they had private networks before, and the VPNs over the public internet or private internet emerged. And we found that, well, that wasn't secure. So we had a lot of firewalls and the growth of the firewall market and networking, very network-centric security approach. Then things started moving to the cloud. So we moved that security to the cloud. What we have today is now people are working from anywhere. Cloud and cloud resources and assets are everywhere. So the software-defined perimeter, I think, addresses the change in the way we work better than any of the network security focused models today.
Yeah,
which I think are the reason for the fundamental flaw.
It also unleashes digital transformation in a way that wasn't possible before. You can now hire people from anywhere, not just work from anywhere. So that unlocks a lot of potential value to labor.
Right.
And it also enables you to connect things that you didn't used to ever want to be connected. Now, using a software-defined perimeter model, you can connect things that, like I'm going to say the electric grid right now is air-gapped, but you can connect things today that you used to not be able to connect because of this different approach and different architecture.
Yep, exactly. Okay, great overview. So let's relate that back down to how you talk about it in the context of zero trust architecture. And this is from the NIST document. So they talk about 4 deployment models. The first 2 are very closely related. So ZTA can be deployed with an enhanced identity governance model, EIG. And in this model, you're really placing a lot of the emphasis on identifying the actors to create the policies. So it might be an open network model where you can provide access to resources, but they're based on identities, roles, and permissions. The problem here is that with this model, actors can still attempt a lot of reconnaissance on the network. There are a lot of DDoS attacks, internal problems. It doesn't really solve the issue because you're putting so much emphasis on identity, and it has to go hand in hand with number 2, which is ZTA being deployed with microsegmentation, switches, firewalls, gateways, those sorts of things. The problem is when you put both of these together, it becomes very complex to manage, and that's what CISOs and security administrators are stuck with today. which is a unbridled and hard to manage and understand set of subnetting, ACL, firewall rules, VPNs, users, key and certificate management. It's a whole sprawl of what we think of as something that can easily be put in a picture and called layered network security, but in reality is very difficult to manage.
And in the real world, you know, that level of complexity can make it almost unworkable, because how do you protect the SCADA systems that may be in manufacturing environments? Or, you know, as you get more and more devices, more and more connections, those interfaces become opportunities for attack. The more interfaces, the more opportunities.
Right. There, you know, there's a vulnerability at every stitch, right?
Yeah,
So
right.
every time you're trying to stitch things together,
Yep.
there's a vulnerability that you may not have identified.
Yeah.
The third ZTA deployment model is a cloud-based portal or device gateway. And we talked about that before, which is simply moving a lot of that security into the cloud, moving the PEP into the cloud. So this might be very much of a SASE model of having a cloud-based gateway and users connect into it, and that's controlling access to your resources. The problem is, as Tom went through, there are performance issues. Those gateways and portals are typically publicly accessible, so their IP addresses are on the public internet, and it still makes it easy for the hackers to attack, and it becomes a single point of failure.
Yeah, and just to clarify, in the terms of Forrester and Gartner, which people may be familiar with, this is the secure service edge or secure access service edge model.
That's right. And then the fourth one, which we think is the model that organizations should be migrating to, is to begin to reframe the way you think about security and reframe the way you think about users, resources, assets, servers, applications, and get rid of the notion of a network-centric security model and move to a software-defined perimeter, where the perimeter is based on where your assets are and where your users are, not on what networks they're connected to or whether they're inside or outside of a firewall or network perimeter. So in this model, the perimeter is not defined by the location of the network. It's defined by the presence of PEP software really on an asset or end user device. You're protecting every resource and subject with a PEP on every asset or gateway. The gateway is protecting downstream assets, typically only in situations where you can't put a PEP on a host, such as protecting legacy OT systems, some IoT devices. And then it's often implemented as an overlay. Here's the beautiful thing, right? You may have an extensive and security strategy that you have today. You don't have to change all of that. With the software-defined perimeter, you can begin to just overlay this on top of what you have, or put it in place in a part of your network, like your DevOps environment, right?
Yeah, it's very modular. It's very modular.
It's very modular, and it will just overlay and improve the security of those assets. And as you get used to the SDP, you'll begin to realize, whoa, we can really dial back a lot of these redundant security models that don't work very well and implement an SDP.
Which is another, I'm sorry to jump in, Cal, another really important thing I think about the SDP model is you now are helping the CIO consolidate their security stack so they don't have dozens and dozens of point solutions. They can simplify that to just, you know, EDR, a SIM, software-defined perimeter, incident response team. So it's a much more rationalized approach to managing your infrastructure.
So much easier to manage. The downside is that it's while the model is easier to manage and much more granular in how you can provision and manage access controls, you have to develop the system, and it has to integrate with your device management system. You have to be able to install the PEPs on the different devices. So it's something that organizations aren't likely to build out themselves, but there are many providers in the space, and there are a lot of advantages to it. I think beyond just the advantages of the SDP and zero trust itself, ZTA also helps you to accelerate compliance, and you can see these different compliance standards on here. It's going to help your organization to meet your access control, identity and authentication, your IAM, your supply chain risk, assurance levels, across so many different standards. If you're a government organization, it's going to accelerate your ability to comply with EO 14028 and M2209, and many of the DoD standards that are emerging right now. And also with IEC 62443 and CMMC for industrial and government critical infrastructure deployments.
And we could do a webinar on each one of these, by the way.
Yeah, absolutely. It's
there's a lot here.
Model.
There's a lot here.
So let's see, anything to wrap things up, Tom? Any things you want to say as we wrap up this session, which just was focused on trying to give the people that have joined here some background on ZTA?
I have a lot of empathy for CISOs and CIOs who their job is to keep their company safe from attacks. And it's a really tough challenge. And the level of attacks, breaches, ransomware, ransom payments are up from 115,000 to 570,000 in 2.5 years. So they have a serious headwind, almost hurricane-like forces that they're fighting out here. So I have a lot of empathy for the challenges they face. And I think zero trust is something that's been recognized as a solution to this, or at least a step improvement to this. And I feel like anything we can do to help folks in that zero trust journey, we would love to be able to do. So we're here to help.
Absolutely. Great. Why don't you say just a little bit about BlastWave?
Yeah, I mean, our company is trying to protect critical infrastructure. Our company is trying to rethink the way the network security operates between entities and resources. And so we've designed this from the ground up, from scratch, kind of thinking about it from first principles. So you have EDR that protects all these endpoints. We want to protect everything in between those endpoints. And that's oftentimes where all the compromise happens. And so what I wake up every day thinking about is how can we help make our customers more secure? How can we make it easier for them to manage this? And how can we make it in such a way that is so high performance that they're not even aware how secure it is? And I think that's what our mission is, and that's what we're trying to do at BlastWave.
Right. Okay, we have a question here. It's, if zero trust first spawned in 2010, why did it take so long to become widely accepted as the best path forward? From my perspective, it's a huge mindset change, right? There is so much gravity in terms of how we think about security today. And it is so grounded in a network-focused approach. And it's very difficult to talk to organizations about how to let that go and think about protecting each individual asset rather than thinking about protecting those assets with a network. It's taken a long time because while those notions have been around, it was only in a few years ago, 2020, that NIST came out with the zero trust architecture. And so this is still something that organizations are grappling with. And in our next webinar, we're going to talk about software-defined perimeter and what it is, how to dig deeply into it, and how to implement it. I would encourage you, if you have a phone, here's a QR code. download our white paper on ZTNA. It's very detailed. It's not a 3-page white paper. It's I don't know, what is it, like 40 pages or something like that, 30 pages. It's a really nice in-depth treatment that steps you through zero trust, SDP, how to think about it and what's important, and also about how you can implement it.
Yeah.
Um,
I'm going to take a kind of question I see. How long does it, I'm going to take two questions. How long does it take to move forward with the zero trust framework? Well, obviously this varies a lot on the size of your organization, the complexity of your organization, the heterogeneity of the devices that you're managing. And so it's a complex, it's based on the complexity of your environment. It also depends on what you have in place. And so I think it can vary dramatically from as little as, 3 to 6 months. But most of these things are, 1 to 2 year journeys. So that's kind of what I've seen in terms of how long it takes to move to a zero trust framework. And then the next question that I was going to ask is it says, it seems as if half of cybersecurity network solutions claim to deliver zero trust, like I mentioned at RSA. Is there a shortcut or a framework that can separate fact from fiction? And I think there is. I mean, fundamentally, zero trust assumes there is no perimeter. And so as you think about attributes that assume there is no perimeter, where you look at the identity of the person, you have session-based authentication, you look at the behavioral characteristics and other data to validate that this is the person who they say they are. So I think that's one thing. I think the second big tenet is that zero trust is not a product. This is important. Zero trust is a framework. It's a way of life. And if anyone claims to have a zero trust product, where if you buy our product, you now have zero trust, they're full of it. And I would look elsewhere. So those are the two questions I figured I'd answer, Cal.
That's great. Thank you. There was another question on, is software-defined perimeter applicable for manufacturing environments? I would say absolutely, and for a number of reasons. One is it accelerates the ability to comply with phishing-resistant MFA. It overlays on a network, fits nicely within a SCADA, ICS, or Purdue model. And third, it's easy. It's going to be easier to implement than more traditional ways that you think about secure remote access and VPN access, for example. But we're going to go into those details in our next webinar next week on software-defined, perimeter-defined, and we hope that you'll join us there. Here's a QR code link to sign up for that as well. We hope you'll join us.
Yeah, and by the way, I did answer one of those questions right at the end. So I just went ahead and wrote it out, but that was just people were asking what percentage of organizations have adopted zero trust. And the Okta does produce the State of Zero Trust report, and so they did in that report show that the adoptions doubled 24 to 55%. So, and then the next report that comes out should be, I think we should maybe be in the 70s. Maybe we could have a prediction, Cal, that by the end of the year, we've got adoption above 75%.
There we go. Okay, I'm gonna say 70.
You're gonna take the under?
I'm gonna take the under.
Okay.
All right. With that, just thanks everyone. I know this is a lot to get into, but we hope this was useful, and we hope you'll continue to take this journey with us towards zero trust.
Yep. And I just saw another question. Are insurance companies requiring zero trust implementation in order to get coverage? Not universally, but I think they're going to move in that direction. And I think within a year, another prediction, insurance companies are going to start requiring zero trust implementations in order to get a policy. So.
Great.
All right.
Thanks,
Thank
Tom.
you very much. And we'll see you at the Software Defined Perimeter webinar.
Exactly.
Don't forget to download the ZTNA white paper by scanning the QR code or follow the link below. Join us for part 2 of our Zero Trust webinar series, Software-defined perimeter defined.